This one is a potentiometer. We'll learn about this maybe in the following class. So potentiometer, listen, this has got 3 terminal. This will basically allow the different, this is a fixed voltage source of 12 volt, and we need some 0.1, 0.2, 0.3 different very small amount of voltages, right? So basically this device will allow this 3 terminal device, that is terminal A, that is terminal B, and that is C. This 3 terminal device will allow this huge voltage to be segmented into small voltages and appeared across the load. Load, that means the device we use, maybe the diode will be the load here. I should have done this experiment first, then you would have understood the matter quite easily. But listen, I will again tell you how this 3 terminal device works. Let's see. This is a potentiometer, exactly. The resistance between A and B, this is A and this is B. Okay. So this potentiometer is a 3 terminal device. Listen, it's a 3 terminal device. So exactly this course starts with this experiment, the diode experiment. But somehow last year we have had some problems with the students with understanding these and also voltage and current measurements. They do have to repeatedly use it again and again. The problem is they didn't understand the fact. So that is why this year we have started experiment on from measuring voltage and current, and then we move to potentiometer, and then gradually we move to somewhere diode. So listen, whatever. You should have understood this first. Listen. So the middle terminal has got a kind of carbon with it, and the carbon is whipping over the resistor. So if it is 5 kilo ohm total, divide into 5 sections. So this is one section makes up 1 kilo ohm, right? So listen, for now, there is the middle terminal. There is a kind of, listen. These are the potentiometers, and you see this in numbers inside the computer. These are things, the potentiometers, and also these things, the fan regulator. These are all potentiometers. They are allowing different voltages across the device. Maybe the fan, if I am allowing low voltage with this potentiometer, that means the fan will move slowly. If I am allowing high voltage, the fan will move really fast. So that's what is happening. Okay, listen. So exactly the middle terminal can be turned left or right, like this one, right? So once I am turning it left, this carbon brush which is whipping over the left side here. Do you see there at the car front there is a front glass, and over that glass there is a wiper. Once there is rain over it, it is wiping out. So there is happening here. This wiper is wiping over this resistance. So for now, listen. Once I am turning it very left, which means at this area, in between, okay, if it is A, it is C, it is B. Between A and C, it is always 5 kilo ohm, sorry. The resistance is always 5 kilo ohm fixed. But between A and B, we can fix the resistance according to our requirements. Let's see. Once I am turning it at the very left, what happens? At the very left side, I will ask questions because I am explaining it. Even though there will be no experiment on it, but I will ask because I am explaining something, right? So this will be included. So at the very left, the carbon is there, right? So right now, if electron pass through this way, it faces no resistance because it starts here, right? Got it? Which means if 12 volt is applied, all 12 volt will be there. No voltage will be dropped. Say for example 1 kilo ohm give a drop of 1 volt or 2 volt. Okay. So that means if, okay, let us turn it somewhat right. If I am turning it a bit right, what will happen? Maybe the carbon brush will come here, right? And up to this. So they are allowing some resistance between A and B for now. So if how much it is? Maybe 1 kilo ohm for now. So 1 kilo ohm is giving a drop of 2 volt. So which means 12 volt, 2 volt will be dropped, 10 volt will be there, right? So if I am turning it more and more right, this will be wiped more and more right, allowing more resistance in between A and B terminal, and that is how the more voltage will be dropped across this and the less voltage will be to the output. So that is how we can vary the voltage using this potentiometer. right? So connection, the A will be connected to the battery positive and battery negative will be connected to C, and middle terminal will be connected to the source, I mean the load, right? And load negative will be connected to the negative. That's how it is connected. So let's see how we are connecting it here. So I'm just giving a brief on it. So let's see. This is, see, first terminal of the battery which is connected to A, and other terminal is to C, right? As I have shown it. And the middle terminal will be connected to a resistor. This resistor, I'll ask that why this resistor is used, right? This is used because to protect the diode from burning out. Once there is a huge amount of current flowing, the diode will burn out. So to protect the diode from burning out, this resistance is used. It is a current limiting resistor. It is called what? Current limiting. Its job is just to limit the current so that the diode does not burn. Okay. And I have told you at the very first class that every IC or every component will have a resistors connected in it in series, because that resistor's job is just to limit the current across the resistors, so that the resistor across the ICs, so that it doesn't burn out. Okay, listen. After that, we will use an ammeter to measure the current, forward current. The diode is now forward biased. Okay, let me connect the diode first. So this is the diode symbol. That is how the diode is symbolized. And this portion is P type, and this portion is N type. Got it? And after that, it will come back to C terminal or negative. So, and a voltmeter will be connected in between the diode to measure V. That's V. That is forward voltage, right? So P is connected with the positive, which means the diode is in forward bias state, right? So that is the forward characteristics of the diode. Got it? Any question regarding this? Okay, listen. Now your job is just look at this. What if we find things like that, right? How this thing really make the diode characteristics curve. Let's see. If we plot, where is that? If we plot a graph like this, across the vertical axis, listen, across the vertical axis there will be voltage, current in milliampere, the current we have had here, and across the horizontal axis the voltage in volt. Listen, for now if we plot voltages here, what is the voltage? 0.1, 0.2, 0.3, that's what we will apply for now. 0.4, 0.5, 0.6 and 0.7. Got it? And current, different currents, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and even more. So one mark will indicate 1 volt, 1 milliampere, right? So for now, that's the table. 0.1 volt, that is this. No current for this, right? 0.2, no currents. 0.3, no currents. 0.4, a bit current but less than 1 milliampere. 0.5, also less than, a bit but less than 1. And 0.6, greater than 2. So which is here, right? At 0.7, it is more than 15, maybe here, right? So if you add this, make a scatter diagram, what will you see? Things becomes like this, right? So that is what the characteristics curve of the diode. That's what we'll make here. Got it? And you will have to plot this graph in a graph paper in the report. Got it? Do you understand how diode behaves with these values? Right now we would like to see that value here practically. So that's the job. Okay? Do you see that? Okay. We need a 3-terminal. Okay, that's the 12 volt, positive 12 and negative 12. We can use this for now. We need a 3-terminal device, what we know as potentiometer, right? You are allowed in the next group. This group is not working for this. Okay, so ABC 3-terminal device. Okay, then there is a resistor. You see that? You see that there is a resistor? So you can have a resistor over here. This R1. This is one terminal, this is another terminal of this resistor. Got it? Huh? Everybody understands?
Yes, sir.
Okay. Okay, listen. And after that, emitter. So this one is the emitter. Does it look like as if it is an emitter?
Yes, sir.
Okay, it is switched on for now. So can you see MA and DC, something like this? It is written, right? That's an emitter for now. Okay. And voltmeter just taking this knob to V. Taking this knob to V makes it voltmeter. Write this, right? Okay. Is that clear? I think so clear, right? Any complaint from you people? Okay. Complaints is always, problematic. Okay, listen. And complaints in the exam hall is always like, kind of embarrassing situation. While asking you a question and you're giving answer that because this happened. That is not the answer. When you were sitting for an exam, that means what? You were supposed to answer to what was asked. Either you know it, you are supposed to know that. If you do not know that, it's your fault, completely your fault. You cannot have reasons that it's okay for this it happened. Someone came after the exam and told me that I was sleeping. No one. We need ammeter. We have that. We need voltmeter, right? And one thing we need is the diode. Can you see in the board there is a diode. This diode is basically, listen. This diode is basically inserted inside the board. And listen, this diode inserted like this, so that the P portion stays in that side and N portion is this side. So symbol is this one. P portion is there and N portion is here. Do you see that?
Yes, D1.
Right?
D1.
Got it? Okay. Okay, I think it is inserted this way. Now let's make the connection. First of all, you come. Take it. Start with the 12 volt positive. Everybody follow her. Yeah, that's the positive of 12 volt. Will be connected to
See the
A.
circuit.
Will be positive. 12 volt will be connected to A, right?
A.
So connect it with A. Where is A? Okay. And negative 12, which is this.
Negative 12.
Yes, connect it with a. Look at where it is connected. C. Is that okay? Huh? Okay. Then the middle terminal, which is B, right? You do that. Yes. Connect it. Okay. Middle terminal will be connected. Where? To the resistor. So we have a resistor. You understand? Okay. And then after the resistor there is an emitter, right? Do you see that? So this is the two props of the emitter, right? We can connect this prop here after the resistor, right?
Diode.
Can you see? Another portion of the emitter will be connected to diode P type. Diode
P type.
P type. Oh, which one is P type? Which one you think? Okay, yes. Here, right? Is that okay?
Yes.
After the P type there is N, right? So this one is N, right? This one is connected. Can you see? There is a connection, right? It is very much visible, right? So which is here. Got it?
Okay. Yes, sir.
And hey everyone, can you see the N is here, right? But it is connected up to this terminal. It is very much visible, right?
Yes, sir.
Maybe you people are sometime connected with someone else is not visible. It is visible only when I sometimes peek through the window and see them sitting together, talking together. That means they are connected. Okay. The C, I mean this N type is connected to C. Got it? So the connection is almost done, right?
Yes, sir.
And we are supposed to connect what? Voltmeter. Who can tell me how the voltmeter is connected
In parallel.
Okay, you tell me where to connect. who the, I mean,
The 2% of
somebody very smart to tell me.
I am.
What? Yes,
Can
tell
I-
me. Yes, yours.
the 2% of diode
From the positive of the diode
Yes, here.
and from the ground of the diode.
Yes.
good point of view.
Can you see? Right? Okay. But I cannot hold it, right? So there is an option. I can put it here, right? And this one.
Here and this one.
Got it?
Yes.
Is that okay?
Okay.
Yes.
Okay. So, do you have any problem with this connection? You will be asked, make this connection. I'll draw the circuit, you will have to make this.
So circuit will be drawn.
I will draw it,
Okay.
or I will ask you to draw the diode characteristic circuit. Only I ask that.
Little
Sort of
text
things
problem.
like this. Exactly not this. If this, then this is already, the question is leaked, right? So I don't think exactly this. There will be something like this. Got it?
Sir,
Yes.
sir, why we draw this easy line B?
It's a resistor. Exactly in between A and C, this is a resistor. Right? Oh yeah.
Sorry, I can see.
Yesterday, one I was the machine exam was taken. So there is a kind of khas, right? So one student was asked that there is a khaskata will look clearless. It's also any question regarding the connection?
Sir,
No.
that's okay.
Now we'll start working. Let's see at the very beginning. Okay. This is the current. This will show the current, right? So hold it, right? Right. And I am holding it. Voltage and that current, right? Okay, listen. At the very first time, we set very small voltage, which is 0.1, but 0.1 is too small to set. Maybe it's 0.2 for now, right? At 0.2, what is the current? Zero. That means 0.2 volt is not enough to break the what?
Barriers.
Barrier, right? Take one digit after the point. So 0.2 volt, right? 0.1 is not possible to set. So that makes 0 milliampere current. Do you see everyone? Is that okay?
Yes, sir.
Huh? Anyone? Next, you set it. Somebody, you first set it 0.3. Okay, then 0.1 also. If as 0.1 is 0, as 0.2 is 0, 0.1 obviously was 0, right? So 0.1, 0.2, that makes 0, 0, right?
Yes.
And now set it with this. Set the voltage
Rotate
0.3
this
volt.
continue.
Slowly, so slow.
Aste.
Doesn't make any sense.
এই তো
Yeah.
আরেকটু
Oh.
ও একটু এই
Okay,
yes,
okay,
yes, yes.
okay, fine. It's very close. Okay. Can you see it's 0.3,
Yes, sir.
right? 0.3, right? Right?
Yes, sir.
Is there any current for that? So still the wall is not broken, right? If somebody is knocking someone, but she's not responding, maybe like this. And what happened? And after that 0.4 for now, I have increased it, right?
0.04.
So I told you at 0.4 there will be some positive response, and some bricks might be broken, right? Right? So still some response is being what? Observed. So which is 0.04 milliampere. Write it down. Where is the script? That is what you have to write in your report. But do we see what we are expected to? Right? Okay. Wow, it is just it was inside your bag.
Quite calm and keep it safe.
Hey, listen, do hurry. And then let's make it 0.5, right? Okay, I'm increasing, or somebody else interested you put it here. 0.5, make it 0.5. Yeah, it's enough. It was already 0.5. Okay, put it there. At 0.5, do you see it's 0.5? Huh?
Current is 2.5.
Is that okay?
0.2.
0.5, right? Okay, is that 0.5? Does it? How much current is there?
0.25.
Huh? 0.25, right? It is still less than 1 milliampere, but 0.25. There are some currents, right? But increased. Okay. Okay, someone else. You have done. So you start with make it 0.6. Current is increasing. Do you see that?
Yes.
Okay, it's okay. It's okay. This is 0.6.
Yes.
What is the current for that? Over 1 milliampere, right? 1 point something. Record it. Record. This is the exact value. The one I have given was
1.73.
just okay. Right? Any question? Okay. Now. Okay.
1.72.
Okay. Right now. Listen. Listen. Look at this.
Point.
Now I am setting it. Listen. After this, there is no problem, right? Then 0.7. I'm setting it 0.7 myself. This see current is increasing very quickly for now. Huh? Is that? It is not yet 0.7. It is not yet 0.7, but current is increasing. Right?
Yes.
Okay. It has become 5. Very high, very high, very high, very high. See? 10. But it's still not 0.7. But it becomes 10. So current is rising very sharply for now, right?
Yes.
Right now it is 0.7. This is now 0.7, but current has been 14.
14.45.
Right? Do you see? Current has been 14.
14.45.
Everyone, can you see that?
4.7.
At 0.7, it becomes 14, which is normal conductor current. So now diode becomes full conducting. Got it? So okay, record it. And if you make the diagram I have shown you, right? That's what it's all about. Diode characteristics, right?